question of whether Romex wiring can be used above the third floor of a high-rise building is addressed by considering the National Electrical Code, or NEC, and local building codes. Romex, officially known as non-metallic sheath cable, is a common type of electrical wiring used primarily in residential construction. Its construction typically consists of two or more insulated conductors surrounded by a non-metallic outer sheath. The NEC outlines regulations for the use of Romex in various types of buildings. The primary concern regarding the use of Romex in high-rise buildings often revolves around fire safety. High-rise structures present unique challenges in the event of a fire, due to their height and the potential for rapid fire spread. Consequently, building codes often impose stricter requirements for materials used in these buildings to enhance fire resistance and prevent the spread of flames and smoke. The NEC generally permits the use of Romex in types Roman 3, Roman 4, and V construction, which typically include residential buildings and some commercial structures. However, restrictions may apply based on the height of the building and the specific occupancy classification. For example, some jurisdictions may restrict the use of Romex in high-rise residential buildings above a certain floor level, often the third floor, due to concerns about fire safety. In these cases, alternative wiring methods, such as using metal conduit or cable with a higher fire resistance rating, may be required. The rationale behind these restrictions is to minimize the risk of fire spreading through concealed spaces within the building, such as walls and ceilings. Metal conduit provides a fire-resistant barrier that can contain a fire and prevent it from spreading to other areas. Similarly, cables with a higher fire resistance rating are designed to withstand high temperatures and resist flame propagation. It's crucial to consult local building codes and regulations to determine the specific requirements for electrical wiring in high-rise buildings in a given area. Local codes may be more stringent than the NEC, and they may vary depending on factors such as the building's occupancy, height, and fire suppression systems. Electrical inspectors and building officials can provide guidance on the applicable codes and ensure compliance with safety standards. When considering the use of Romex in a high-rise building, several factors should be taken into account. Firstly, the type of construction is a primary determinant. As mentioned earlier, the NEC permits Romex in types Roman 3, Roman 4, and V construction, but restrictions may apply in high-rise buildings. Secondly, the occupancy classification of the building is important. Residential buildings typically have different requirements than commercial buildings, and high-rise residential buildings may have additional restrictions. Thirdly, the presence of fire suppression systems, such as sprinklers, can influence the requirements for electrical wiring. Buildings with comprehensive fire suppression systems may be subject to less stringent restrictions. Fourthly, the local building codes and regulations should be carefully reviewed. These codes may specify the types of wiring methods permitted in high-rise buildings, as well as any additional requirements for fire resistance and safety. Fifthly, the advice of electrical engineers and building officials should be sought. These professionals can provide expert guidance on the applicable codes and ensure that the electrical wiring system complies with all safety standards. In summary, the use of Romex above the third floor of a high-rise building is generally permitted under certain conditions, but restrictions may apply based on the type of construction, occupancy classification, and local building codes. It's essential to consult the NEC and local codes, and to seek the advice of qualified professionals to ensure that the electrical wiring system is safe and compliant. Always prioritize fire safety and adhere to the strictest requirements to protect occupants and property. In addition to the general guidelines, there are specific considerations to keep in mind when using Romex in any building, including high-rise structures. Firstly, Romex should be installed in accordance with the NEC and manufacturer's instructions. This includes proper support and protection of the cable, as well as correct termination and splicing. Secondly, Romex should not be used in wet or damp locations unless it is specifically listed for such use. In these locations, alternative wiring methods, such as using waterproof cable or conduit, should be considered. Thirdly, Romex should be protected from physical damage. It should not be installed in areas where it is likely to be exposed to impact, abrasion, or other forms of damage. Fourthly, Romex should be properly grounded. The grounding conductor in the cable should be connected to a grounding electrode system as required by the NEC. Fifthly, Romex should be inspected regularly for signs of damage or deterioration. Any damaged or deteriorated cable should be replaced immediately. The NEC provides detailed requirements for the installation and use of Romex. Article 334 of the NEC covers non-metallic sheathed cable, including Romex. This article specifies the types of buildings where Romex is permitted, as well as the conditions under which it can be used. It also includes requirements for the installation, support, and protection of Romex. Some key requirements in Article 334 include the following. Firstly, Romex must be supported at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, and fittings. Secondly, Romex must be protected from physical damage where it is exposed. Thirdly, Romex must not be used in hazardous locations, such as areas where flammable materials are present. Fourthly, Romex must be installed in accordance with its listing and labeling. Fifthly, Romex must be properly grounded. In addition to the NEC, local building codes may impose additional requirements for the use of Romex. These codes may vary depending on the jurisdiction, so it's essential to consult the local building department to determine the specific requirements for a given area. Local codes may restrict the use of Romex in certain types of buildings or above certain floor levels. They may also require the use of alternative wiring methods in specific situations. For example, some jurisdictions may require the use of metal conduit in high-rise buildings to provide additional fire protection. In conclusion, the use of Romex above the third floor of a high-rise building is subject to both the NEC and local building codes. It's important to consult both of these sources, as well as to seek the advice of qualified professionals to ensure that the electrical wiring system is safe and compliant. Always prioritize fire safety and adhere to the strictest requirements to protect occupants and property. In general, the NEC permits the use of Romex in types Roman III, Roman IV, and V construction, which typically include residential buildings. However, restrictions may apply based on the height of the building and the specific occupancy classification. Local building codes may be more stringent than the NEC, and they may vary depending on factors such as the building's occupancy height and fire suppression systems. In addition to the code requirements, it's important to consider the practical aspects of using Romex in high-rise buildings. Romex is relatively easy to install and is less expensive than some other wiring methods, such as metal conduit. However, it is also more susceptible to physical damage and may not be suitable for use in all locations. Metal conduit provides better protection against physical damage and can also help to contain a fire. However, it is more expensive to install and may require more skilled labor. The decision of whether to use Romex or metal conduit in a high-rise building should be based on a careful consideration of the code requirements, the practical aspects of installation, and the overall fire safety goals. It's important to work with qualified electrical engineers and contractors to ensure that the wiring system is safe, compliant, and appropriate for the specific application. When selecting electrical wiring for a high-rise building, it's also important to consider the long-term maintenance and reliability of the system. Romex has a shorter lifespan than some other wiring methods, and it may need to be replaced more frequently. Metal conduit, on the other hand, can last for many years with minimal maintenance. The cost of replacing wiring in a high-rise building can be significant, so it's important to choose a wiring method that is durable and reliable. In addition to the type of wiring, it's also important to select high-quality electrical components such as outlets, switches, and circuit breakers. These components should be listed by a recognized testing laboratory such as Underwriters Laboratories or UL, and should be installed in accordance with the NEC and manufacturer's instructions. Poor quality electrical components can be a fire hazard, so it's important to invest in reliable products. Regular inspections and maintenance are essential for ensuring the safety and reliability of the electrical system in a high-rise building. These inspections should be performed by qualified electricians and should include a thorough examination of the wiring, components, and grounding system. Any damaged or deteriorated wiring or component should be replaced immediately. The grounding system should be tested to ensure that it is providing adequate protection against electrical shock. In summary, the use of Romex above the third floor of a high-rise building is a complex issue that requires careful consideration of the NEC local building codes and practical aspects of installation and maintenance. It's important to work with qualified professionals to ensure that the wiring system is safe, compliant, and appropriate for the specific application. Always prioritize fire safety and adhere to the strictest requirements to protect occupants and property. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified electrical engineers, contractors, and building officials to ensure compliance with all applicable codes and regulations. Fire safety is of paramount importance in high-rise buildings, and the electrical wiring system plays a critical role in preventing and containing fires. By following the code requirements, using high-quality materials, and performing regular inspections and maintenance, it's possible to create a safe and reliable electrical system that protects occupants and property.